ways of looking at these compounds that we have little knowledge of. We don't know what sorts of health effects they have, which sorts of biological and environmental health effects that they have. And certainly some of these compounds are present at very low levels, which doesn't mean that they don't have detectable toxicity. So we need a way to detect these low concentrations of these unknown chemicals. So right now, the way that we handle these compounds of contaminants of emerging concern is analytical chemistry. So as I mentioned before, we may pick some target chemicals which have some known effects or fit into a known class of compound, design analytical tools to be able to extract those and to quantify their presence in particular matrices. And then model that to see how much we may be exposed to in water, model how much would be expected to end up in different biota within the environment. And for many compounds, we can use this approach and get a good handle on the overall quality of that particular water sample. Where we run into problems is for those compounds that we do not know if they're present, or if we don't know what their degradation or persistence is in the environment. And the other overriding factor when you start to think about these complex mixtures of chemicals is that they are present in very complicated mixtures and complicated matrices that may change over time. So, of course, very challenging to start looking at all of these different unknowns coming from a variety of different sources. And the challenges are plenty, and I'm showing three major challenges here. So these chemicals, even though we can detect them, we can measure them, we may not know what their toxicity is. These fit that definition of an emerging contaminant, where we do not have background knowledge on the types of toxicity or at what doses these chemicals cause a toxic response. We may have difficulty in the methods that are required to detect certain unknowns. If we don't know they're there, we don't know how to develop analytical tools to measure them. And then finally, something that I suggested before is the fact that these are present as complex mixtures. And so we have to come to grips with how these chemicals are interacting with each other, how they might be able to have additive effects, synergistic effects, or more than additive, or one chemical may be interfering or antagonizing the effect of another chemical. So this complexity and detection limits, all of these things add together into the fact that we need better tools to assess the quality of different water samples. And what we're looking for is a way to look at the sum effect of all of these chemicals that are present at a given time in a given water source. And what I'm going to be talking about is one potential avenue that we can explore to look at that cumulative effect. And that's using bioassays. In particular, bioassays that are looking at particular mechanisms or effects that we can use. So here's the general approach that we're going to describe, that is starting with looking at different water samples and hopefully at the end of the process being able to make some decisions about the quality of that water or the effect that a treatment has had on the quality of that water. And I've divided this up into four major steps that are required to use these bioanalytical tools. The first is sample collection. Second is sample extraction. The third would be picking the toxicologic or pharmacological endpoint that you want to examine. And then the fourth is trying to match a bioassay for that endpoint that you have selected to interrogate. And we are going to spend the vast majority of this talk on point number 4, but I thought I would spend this slide at least talking about the first 3 steps in this process, just so that you can put the bioassays into context. So the first, of course, is sample collection. And this particular talk is dealing with water quality. And of course, these assays can be used for a variety of different types of water. They're quite frequently used for looking at wastewater treatment facilities, recycling programs. These could be environmental samples, surface water, groundwater. These could be from sediment samples, sediment water, or it could be any step within the water recycling and purification process. These can also be from other biological matrices as well, although we won't be talking about these today. But things like food,